everybody, I'm Brian here at Nurse Hub, and welcome to our lesson on expanding fractions. You ready? Hey everybody, welcome to Expanding Fractions on the T's with me, Brian. So let's get right to it. Our goal for today is we will be able to expand fractions and determine if expanded fractions are equivalent. What we mean by expanding fractions, it's to create equivalent fractions using larger numbers than those in the original. Sometimes we just want to create equivalent fractions using these larger numbers. So for example, if we had 1/2, we want to create equivalent fractions. So 4/8, 50/100ths, all of these are going to be expanded from 1/2. And again, most important part, they are all equivalent to one another. What do equivalent fractions mean? These are fractions that have different numerators and denominators but have the same value. So again, like we showed you before, if we have something like 1/2 would be equal to 4/8, would also be equal to 1,000 over 2,000. So even though these fractions look different, the values of them are the exact same. So key point number 1, to expand a single fraction, multiply the numerator and the denominator by the same number. So say for example we have something like 3/7, and we want to expand this fraction. If I multiply my numerator by 4, I also have to multiply my denominator by 4. So 3 times 4 is 12, 7 times 4 is 28. So what we just shown is that 3/7 is equal to 12/28. And in the next slide, we're going to talk why this works. All right, so key point number 2, and this is a lot of words, but this is why it works. This is why it has to be the same number. When you multiply the numerator and denominator by the same number, you are really multiplying the original fraction by one whole. And remember, the thing that we learned very early on, if you multiply anything by 1, it stays the exact same value. So let's look at just a quick example. So say we had 4/5, and I'm going to expand my fraction. So I'm going to say I'm going to multiply this by 6, and I'm going to multiply my denominator by 6. So what I'm really doing is I'm multiplying it by 6 over 6. What is 6 divided by 6? That's equal to 1. So this yellow circle, what I just circled right here, is really equivalent to 1 whole. But the way it looks as a fraction is 4 times 6 is 24, 5 times 6 is 30. So although it looks like 24/30ths, it is equivalent to 4/5 because we really just multiplied it by another version of 1 whole. Remember, when the numerator and denominator have the same value, it's also equivalent to 1 whole. Why do we need to do this? This is so important because when we add or subtract fractions that don't have the same denominators, we are going to have to expand fractions to find those common denominators and make equivalent fractions. We're going to jump into our sample questions. You always have your 3 options. You can do them with me, you can do them on your own, or a little mix of all of it. So sample question number 1, create 3 equivalent fractions to 2/5. So what I'm going to do is I'm just going to write 2/5 out 3 times. And the cool part about this is it did not tell you any number that you have to use. So we may have different answers, and that's totally fine. The most important part is that if you expanded your fractions, you had to have multiplied the numerator and denominator by the same number. So let's just try one. Let's go with times 4 times 4. So that means this fraction would be 2 times 4 is 8. 5 times 4 is 20. So 8/20ths is equal to 2/5. Let's try 100. 2 times 100, 5 times 100. Making sure I multiply the numerator and denominator by the same number. 2 times 100 is 200. 5 times 100 is 500. Therefore, 2/5 is equal to 200 500ths. Final one, let's make it 2 times 15. over 5 times 15. 2 times 15 is 30. 5 times 15 is 75. So 2/5 is equal to 30 75ths. And 8 20ths is equal to 200 500ths is also equal to 30 75ths. So we created these different equivalent fractions by expanding that have the same value. We are going to complete the expanded fraction. If we look, we know that both the numerator and denominator have to have been multiplied by the same number. So what I'm really thinking is 7 times what equals 28. Why am I focused on the 7? Because this row of denominators is complete. We're missing something from up top. I know that 7 times 4 is equal to 28. So that means both of these numbers must have been multiplied by 4. Since 4 times 4 is equal to 16, the missing number right here there we go, must be 16. We completed our expanded fraction. We're going to complete another expanded fraction. As you see, the denominator is missing, but we still follow the same idea. So both of these numbers, the 5 and the 8, the numerator and denominator, are multiplied by the same number. So what we're really thinking is 5 times what equals 35. We focus on the numerator because we have two sets of numerators, which means we can figure out what we call our multiplier. What was our numerator multiplied by? So I know that 5 times 7 is equal to 35. So we must have a 7 as our multiplier. So 5 times 7, 8 times 7. So I know that 8 times 7 is equal to 56. Therefore, our missing number must be 56. So our fraction is 35/56. We look, are the fractions 5/25 and 25/36 equivalent? So let's look. So I have 5/6 and I have 25/36. So we're going to look at each row separately to find its multiplier. So I'm going to look at what number was multiplied by 5 to get 25, and what number was multiplied by 6 to get 36. So I know that 5 times 5 gets me 25, and that 6 times 6 gets me 36. What I notice is that these two are not the same number. So they're not equivalent. Multiplying something by 5/6 is not the same as multiplying something by 1 whole. To keep a fractions equivalent, you have to multiply the numerator and denominator by the same number. So with this, which of the following fractions is not equivalent to 3/4? What we can actually do is let's put 3/4 underneath each one. And this is very similar to the last problem, but instead, we're going to do this 4 times to check. So I'm going to look at 3/4 and 45/60ths first. So I'm going to see 3 times what gets me 45, and 4 times what would get me 60. I know 3 times 15 would get me 45. You could have done that division-wise. 45 divided by 3 would be 15. 16 divided by 4, or 60 divided by 4 is also going to give you 15, which means 4 times 15 is 60. These are both the same. So this is equivalent. So it does work. So we're going to keep it moving. So then we have 18/24. I'm going to look. 3 times what gives me 18? 4 times what gives me 24? I know 3 times 6 is 18. 4 times 6 is 24. These are both the same. It is equivalent. So we're going to put E for equivalent. All right, so let's move it on. Let's keep it moving. We have 24/28. So I'm thinking 3 times what is 24? 4 times what is 28? I know 3 times 8 is 24, and 4 times 7 is 28. These are not the same number. So these are not equivalent. And I just like to check with our final one. So if we have 30/40ths, I look 3 times what is 30, 4 times what is 40, 3 times 10 is 30, 4 times 10 is 40. These are the same number. This is equivalent. So our correct answer is going to be C. 24/28 is not equivalent to 3/4. All right, you've come to the end of our expanding fractions lesson. Congratulations. Another one's in the books. Now go forth, go practice, and we can't wait to see you for our next one.
Y'all, that was wild, but congratulations on crushing another lesson here at Nurse Hub. You should be proud and then continue working to make sure you fully understand everything that you just watched. Remember, practice is the only thing that we need to make ourselves better at all of these topics. Good luck, and I hope to see you soon.